Hi all! In this video we'll be going over the two types of lenses and how to draw a ray tracing diagram from a convex lens. So our learning goals is to understand how to use the principal axes to draw the image of an object through a convex or concave lens, and how to use the thin lens formula, and then we'll apply it to the human eye. So the two types of lenses are a convex, and that lens, and a concave lens. And these two lenses are going to look like this. So that's kind of a teardrop, and then this is almost the reverse of it. And each one of these is going to have focal points on either side of the lens, but it won't necessarily use all of them. So, so we can do now, we can write down some properties. Of these lenses. So for a convex lens, if you have incoming light and it's all horizontal, so that means the image is really far away. You can think of something like the sun. And what's going to happen to all these rays is they're going to get converted, focused through the focal point. So this is the incident side and this is the transmitted side. So one thing that we can observe is rays get bent. So this is incident rays. Incident rays get bent to focal point on transmitted side. Now over here on the concave lens, we have the same sort of left-right incoming horizontal incident lenses. And what's going to happen is these are going to diverge, and then if you were to trace back, they would have looked to have originated from this focal point on here, this side. So incident rays originate, I'll put that in quotations because they don't actually, but it looks like they do, from focal point on incident side. So a convex lens is usually used to form a real image, and a concave lens can only form a virtual image. And then this image will be inverted. When real, it is inverted, and then this will be upright. And this has a positive radius of curvature. Going back to the lens major equation. This one has a negative radius of curvature. These are sort of the basic properties. So now, if we clear our screen and look at convex lens basics again, if we redraw the convex lens, and then instead of yellow I'm going to use orange because I think it's going to be a little bit easier to see. We have incoming horizontal light, that should be horizontal. And then what's going to happen is these will be bent so that they go through the focal point on this side. I'm missing it a little bit, but that's because I don't have steady hands. These should be all hitting the focal point. If we made the dot a little bit bigger, and since that's F, that's the focal point. So what we can do is we can define our axes. So this is a 2D system. We're going to have one right here, and that's going to be the plane of the lens. The focal point F is really the distance from plane of the lens to the actual focal point. And then we will also have this, which is the principal axis of lens. So what we want to do right now is just sort of identify which one of these rays. So just for consistency, there's a focal point on both sides. The ones that are the point that's getting focused to is over here. However, there is one over here. So if we pull up PowerPoint, zoom out a little bit, let me go. To here. There are three principal rays. The first ray leaves the object horizontally, and at the plane of the lens, it either, for a convex lens, bends at that plane towards the focal point on the transmitted side, so that's what we have over there. And for a concave lens, if it will do something different. Elizabeth will go over this, but what we need to grab right here is label the first one. So if we come over here, so either this one or this one down here could be our first principal ray. I'll label them both 1 because they both could be it. They're both fulfilling the coming in horizontal and then getting bent at the plane of the lens to go through the focal point. So they both get a 1. So if we pull the PowerPoint back up and we look at this, the second principal ray leaves the object and goes through the origin. The ray is not bent. This ray is the same for either a convex or a concave. So that one's easy to remember because it's going to be the same for the both. So this one right here, it goes through the origin and it's not bent. So we'll label that one as 2. And then the last one, last principal ray, for a convex lens, it leaves the object, passes through the focal point on the incident side, and then it's bent at the plane of the lens and transmitted horizontally. So what we need to do is we need to find a ray that passes through the focal point on the incident side and then leaves horizontally. And it's actually this ray right here again. So what we're trying to do is this simple picture that we're showing, there's actually 3 principal rays that define it, but one of them fulfills the role for 2 of them. So either this top one or this bottom one could be the first principal ray, and then this one right here does the role of 2 rays. So it's a 2-for-1 special. So if we clean this off, and then we actually include an image that's close enough so that all the rays don't come in horizontally, we'll see why these 3 principal rays are useful. So if we have our thin convex lens, we do the plane of the lens and the principal axis of the lens, and then we draw person right here. It's just going to hang out, and then what we need to do is we need to draw our 3 principal axes to figure out, we'll say that there's a focal point here, and then there's a focal point here. So what we're going to do is we are going to draw the first principal ray, comes in horizontally, so this is 1, and then it gets bent near the focal point, and then it keeps on going. Going. The second one, just let me double check. Okay, so I'm saying the second one goes through the origin. So it's going to go through this point right here. So it's going to start at her, go through the origin, keep going down, and that's going to be number 2. And then we have a third ray. It's going to leave from her, go through the focal point, and then get bent horizontally, and I kind of missed it a little bit there, but you get the idea that there'd be something here. What we'd end up with is she would be upside down, and right here. So if we just say a couple of definitional things, so if we call this height of the object, and then this the height of the image, and we say that from the plane of the lens over to here is the object distance L, and then over here from the plane of the lens to the image is a distance I. If we look at the second principal ray, it connects the tops of these two images by a straight line. So we can just do some simple geometry and write that h0 over 0 equals hi over I. So this is just the slope. This is just the, the simple rise over run type thing. Y over x. And then what we can do is we can just multiply the I over. So we'll get I over O equals HI over HO. And then what we can say is that this is going to be the magnitude of the magnification. So we'll define something as the magnification, so how much the image is either stretched or compressed. And since this gets inverted, we'll get a negative sign, but then it'll be I over O, so it's either negative I over O or negative HI over HO. And then the last thing, thin lens formula, is 1 over the focal length equals 1 over the image distance plus 1 over the object distance. So the focal length for a given lens is fixed, so this side is a constant, and then you're just either putting in the image distance to find the object, or the object distance you're putting it in to find the image distance. Okay, thank you very much.